back to another episode of our AKS cost management series. In this video, we'll cover how to right-size your workloads, scale, and run your applications as efficiently as possible. Pods deployed in your AKS cluster consume resources, such as CPU and memory, but not all node resources can be used to run pods. Let's take a single node as an example. A node's total capacity represents the sum of all physical CPU and memory resources available on the node. Kubernetes sets aside a portion of the node resources to run system-related processes such as kubelet, container runtime, kubeproxy, which are all essential for node function. The node has an overhead as some amount of the resources is consumed by the OS itself and not available to the workloads. And a portion of the resources is also reserved for the eviction threshold. This threshold ensures there are at least some amount of available memory on the node at all times to ensure stability. If a node is under memory pressure and the eviction threshold is hit, kubelet will terminate one of the running pods to free up memory. The remainder of the compute is what we call allocatable. Allocatable is a portion of the node's total capacity that can be used to run your pods. Bin packing is a strategy that involves packing your pods onto your node in a way that maximizes allocatable capacity. Pods can be different shapes and sizes, so you can think of this like a game of Tetris. Can you pack in your pods as efficiently as possible to minimize resource waste with infrastructure you're already paying for? One of the keys to effective bin packing is proper management of your pod resource requests and limits. Resource requests define the amount of CPU or memory a pod needs in order to be scheduled to a node. If your pod requests 2 GB of memory, but your node only has 1 allocatable gigabyte, the pod will not be scheduled. It will go into a pending state until the required resources do become available. Resource limits define the maximum CPU or memory a pod is given. This is important to set because these values, if they're improperly set, the pod's actual usage is significantly below the resource requests. This means resource waste. That pod is over-reserving allocatable resources, preventing other pods from getting scheduled. On the other hand, if these values are set too low, and the actual usage is above the limit, your app may get throttled or run into out-of-memory issues. Another way to improve bin packing is to right-size the number of pod replicas for your workload. You can manually scale down the replica count for static workloads if demand is low, but this is not recommended for workloads that experience sudden spikes or bursts in traffic. So this is where workload autoscaling comes into the picture. On AKS, there are 3 types of workload autoscalers: vertical pod autoscaler, horizontal pod autoscaler, and Kubernetes event-driven autoscaling. Horizontal pod autoscaler, or HPA, dynamically increases and decreases the number of pods based on resources demand. When you configure HPA for a given deployment, you define the minimum and maximum number of pod replicas it can scale to. You also define a metric to monitor and base the scaling decisions on, such as CPU or memory utilization. Vertical pod autoscaler, or VPA, scales the pod to have more or less resources by adjusting the pod's requests and limits. VPA has 4 modes of operation on AKS: off, initial, recreate, and auto. In the off mode, no autoscaling actually happens, but VPA will provide recommended request and limit values for your pods, which you can then manually change for additional control. In initial mode, those recommendations will be assigned only during pod creation. Existing pod requests and values will not be updated. In recreate mode, VPA assigns the recommendation values during pod creation and updates existing pods by evicting them when resource requests differ significantly from the new recommendations. In this mode, pods can be continuously deleted and created as the recommended values change. Lastly, auto mode. This is similar to recreate mode, but once in-place updates of pod requests is available, it can be used as a preferred update mechanism, meaning pod evictions won't happen when the request and limit values get updated. You can use HPA and VPA at the same time, but there are a few things to keep in mind. VPA and HPA should not scale on the same CPU and memory metrics. This combination can lead to conflicts as both autoscalers attempt to respond to changes in demand using the same metric. Consider using VPA for CPU or memory in conjunction with HPA for custom metrics to prevent overlap and ensure that each autoscaler focuses on distinct aspects of the workload scaling. Alternatively, you can keep VPA on off mode and get those optimal request and limit recommendations without having the changes applied, while HPA scales your app horizontally based on CPU utilization. The final workload autoscaler is Kubernetes Event-Driven Autoscaling, or KEDA. KEDA dynamically scales your application to meet demand in a sustainable and cost-efficient manner. KEDA can trigger scaling based on a wide range of events and data sources from Azure services. For example, the count of unprocessed events in Azure Event Hub, or the length of message queues in Azure Storage Queue. You simply define a scaled object custom resource definition and indicate the scaler you want to use, the workload type you want to scale, and the minimum and maximum replicas you want to scale to. KEDA then uses a scale controller to monitor all the scaled objects. And when a scaling action is needed, KEDA creates an HPA and feeds the metrics to scale your objects through it. KEDA provides an incredible amount of flexibility to scale not just deployments, but also stateful sets, jobs, or any custom resource you define. By leveraging KEDA, you can ensure your applications scale efficiently based on demand, leading to significant cost savings and optimized resource usage. Ultimately, which workload autoscaler you use depends on your application scenario, but the more you can lean on autoscaling to right size, the more efficiently you can BIM pack and drive cost savings. In the next video, we'll take this one step further and talk about how to layer on infrastructure or node autoscaling to drive additional optimizations.